Hi, welcome to Mathematics with Tom. I am Tom, and today we're going to use the technique of variation of parameters to solve this second order linear differential equation, y double prime plus y equals e to the it. And the reason I picked this example is that if you're not careful, you're going to stumble into an immediate problem. And really the point of this is to show you the power of variation of parameters. Now, first off, the variation of parameters starts by we need to know. So we have to know, need to know the null solution. Need to know the null solution. And we do in this case. We've solved this one before. This one is the null solution is C1 EIT plus C2 e to the minus it. Now, here's where the problem arises, and you probably see it already, is that the null solution already contains what we think should be the particular solution. This is a case of resonance. So what makes this problem interesting is that if I was to use a particular solution, I would deliberately have to put a t into my particular solution and try to solve something like that. Well, let's see how resonance deals with this case. Well, here we go. We're going to just take it from the top. I'm going to assume C1 and C2 are functions of t. For the y particular solution. So y particular, I'm going to write it again. These are now functions of t, C1 e to the it plus C2 e to the minus it. Okay, we take its derivative, so we're going to pick up a y particular prime. This is going to be a C1 I e I t plus, now remember, c is a function, so now then we're going to pick up a C1 prime e to the it. And again, plus, then we have C2 times a minus I e to the minus it plus a C2 prime times an e to the minus it. And then the two terms that have the C2 or the C primes, we let those equal 0. So we say let C1 prime EIT plus C2 prime e to the minus it equal 0, and that is our equation 2. Now, let's continue. So now our y particular is going to be C1I e to the it, and then we're going to have a minus C2I e to the minus it. And now we repeat. We take, y particular prime. Now we find y particular double prime. Y particular double prime. So that's going to be C1 times, that's going to be an I squared. We'll clean that up in a bit. I squared e to the it plus a C1 prime I e to the it. Remember, we're using the product rule here. And then we're going to pick up a minus C2, and then we're going to pick up a minus, well, that's going to be a plus, but then we're going to pick up an I squared. Wow. Okay, and then an e, the minus it, and then we're going to pick up a minus C2 prime I e to the minus it. Okay. Now let's substitute that all back into y particular double prime plus y particular. So, that's a lot. Here we go. It's going to be a c, well, I squared is minus 1, so I'm minus c1 EIT plus c1 prime I e to the IT. And then we're going to pick up a minus c2 e to the minus IT. And then a minus c2 prime I e to the minus IT. Plus, that was just the second derivative. Now we put the first derivative, or no, just the function. So that is c1 e to the IT plus c2 e to the minus IT, and that all equals e to the IT. Wow. Okay, where do we go from here? Well, now we need to grab a red pen. Because, look at this, here's a minus c1 e to the IT plus c1 e to the IT. And here's a minus c2 e to the minus IT plus c2 e to the minus IT. Those are all just opposites. And so what I'm left with is this. I'm left with a c1 prime I e IT minus c2 prime I e to the minus IT equals E IT. And we're going to call that's our equation 1. And I'm going to bring up equation 2 now. Equation 2 is c1 prime e to the IT plus c2 prime e to the minus IT. And that equals 0. That's equation 2. So what I'm going to do now, I'm going to do this in one big step. I'm going to multiply equation 2 by I. So I times equation 2. And I'm going to add that to equation 1. And notice what will happen is the c2 prime terms are going to cancel. And so I'm going to be left with a 2 times c1 prime I e the IT equals E IT. Okay, I know that takes a bit. Double check. If I did something wrong, please shout out, let me know before I continue on. The e to the IT's will cancel. That's just a 1, and I'm going to divide by 2I. So now I have c1 prime is 1 over 2I. 1 over 2I. And so then if I take the integral of both sides, the integral of c1 prime with respect to t, and the integral of 1 over 2I with respect to t, well then I can say that c1 is equal to 1 over 2I times t. Okay, and we're just going to, our constant of integration we're going to assume will be 0 because we've got enough constants we can adjust later. Now I need to go back and solve this. So what I'm going to do is I'm going to put my c1 prime into equation 2. So I'm going to put it into equation 2, and then I can find my c2 prime. So won't have much space left here, so I'm going to go to another screen, and let me just write what I'm going to copy over before we go. So c1 prime is 1 over 2I. So I'm going to take 1 over 2I e to the IT plus c2 prime e to the minus IT equals 0. All right, I will see you on the next page. Okay, here we are. And now we can solve for c2 prime. I'm going to do this in a couple steps. c2 prime e the minus IT is equal to minus 1 over 2 times I e to the positive IT. And then I'm going to multiply both sides by e to the positive IT. So now I have c2 prime equals minus 1 over 2 times I times e to the 2it. Take the integral of both sides, and I'd have c2 is equal to, well, this is going to become minus 1 over, and then I'm going to pick up a 4I squared e to the 2it, and we could probably clean that up a bit because I squared is negative 1, so this is 1/4 e to it. Okay, now let's write our final solution. Well, remember, if we went back and we looked, y particular said you put in c1. Well, c1 we said was 1 over 2I times t times the y1. Well, y1 was e to the it plus, and then we put in c2. Well, c2 is 1/4 e to the 2it times y2. Well, y2 is e to the minus it. And I clean this up, so what I have is y particular equals 1 over 2I times t e to the it plus 1/4 e to the it, because I'm adding my exponents. Now, if I was to write out my complete solution was going to be the null solution plus our particular solution. Well, that's going to be up here, y complete is going to be c1 e to the it plus c2 e to the minus it plus, and now my particular solution is 1 over 2I t e to the it plus 1/4 e to the it. Now you might wonder, what is this? This 1/4 e to the it. Well, that's just another component. That is a like term of y1. And so our final y complete, so really this is like an extra piece, an adjustment to the null solution based on our initial conditions. So really, I can write this as c1 plus 1/4 e to the it plus c2 e to the minus it plus 1 over 2 times it e to the it. And notice that resonance was handled by a variation of parameters without even having to prepare for it. I hope that helps, and thanks for watching.